Hello friends, today I will discuss the Cutset matrix. What is Cutset? It is nothing but a graph with one twig connected to the node and links are connected to the same node. Each Cutset separates a graph into two parts. So to get the Cutset for the given electrical circuit, draw the graph and for the graph assign the current direction for each branch. Then we call that as oriented graph, and from the oriented graph get a tree. And for tree there are two types of branches. One is called the twigs, the shown by thick lines. The other branches are called the links, which are shown by dots. So to get the cut set matrix, first of all, for each cut set it should be noted that how many branches are connected or how many elements are connected to that particular cut set. Similarly, the elements disconnected with that cut set. Once these two are known, so then cut set matrix can be written without much difficulty. So let us say one example. Find the cut set matrix for the following graph. So for this problem, the graph oriented graph is given. So for getting the tree, there is one tree like this for this graph like this. So a tree will not have the closed loop, but they will have the twigs. Twigs means thick lines. This is one, this is one, this is another one. BED or the thick lines. These are also called twigs. So belongs to the tree, and this will not have the closed circuit. But all these branches are connected together, with the nodes. The tree branches, that is called twigs, connected to the all nodes. So how many node twigs that we get for a given graph? So we should know the number of nodes for the given graph. This is one node, this is another node, this is another node, this is another node. There are totally 4 nodes. Once we know the number of nodes, we can decide the number of twigs of the tree, which is given by number of nodes minus 1. That is 4 minus 1 is equal to 3. So whatever tree is drawn for this graph, it must contain only 3 twigs. And similarly, the number of links that tree contains is given by the total number of branches in the oriented graph minus the number of twigs of the particular tree. So that is total number of branches is represented by capital B, and the number of twigs of particular or graph is T, that is represented with T. So B minus T means 5 minus 3 is 2. So this is the tree, and these thick lines are called the twigs, and these dotted lines are called the links. Arrow leaving dot element will get the positive sign, whereas the arrow entering the dot element gets the negative sign, minus 1 in the Cutset matrix. So to get the Cutset matrix, we have to see that there is only one twig associated with one Cutset. So look at this. This is the B cuts twig. So here we can have a one cut set called C1. So this cuts the A, B, C here. So if you separate that means the oriented graph will become two parts like this. So this is upper part whereas the rest will become the second part. Similarly, another cut set also can be formed that is equal to the C2, and this will also have the one twig like this, that is D, and if you cut this automatically this will become one part whereas the other part will become another part. So this is also a cut set. Similarly, here also there is a twig. So here also we can form a cut set like this. So then we get the cut set to 3 like this. So if we separate this, this will make this graph into two parts. This is left part, this is right part. We know the so look at the elements. Element A is entering node 1. Similarly, the other elements B and C elements are leaving the node 1. So elements leaving the node 1 will get the positive sign whereas the element entering the node will get the negative sign like this. For A minus 1 whereas B and C elements are leaving the node 1, so we get here plus 1 plus 1, whereas the disconnected elements D and E should be assigned with zeros like this. Next, set 2, the elements connected to C2 is nothing but AD. A is also leaving and D also leaving the node 2. So they get the positive sign, that is plus 1 AD. This is A plus 1, D plus 1, and rest of the elements B, C, E are disconnected elements, so they get the 0 values like this. Similarly, for cut set 3, the elements connected are EC. The elements connected are E and C, and both these elements current directions is towards the node 4, so they get the minus sign whereas the rest of the elements will get the 0. EC for cut set 3, its node voltage is V3. C will get the minus 1 and E get the minus 1, and rest of the elements will get the zeros. So this is the Cutset matrix for this graph with these cut sets. So the Cutset matrix indicates the relation between the node voltages and branch voltages. Let us take another problem. Find the Cutset matrix for the following graph. So here oriented graph is given and the number of nodes are also given, that is this is 1 2 3 4, there are totally 4 nodes and the elements are A B C D E F G. So there are totally 7 elements or 7 branches. So once it is known, then we can calculate the number of ticks for this graph is nothing but total number of nodes minus 1. Total nodes are 4. Minus 1 will give us 3. The number of links, capital L, is nothing but total branches minus 6. That is 7 minus 3 is equal to 4. This number of twigs will indicate the number of cut sets that can be formed for this graph. So then the number of links that is possible is given by total branches minus total twigs. So total number of branches are known as 7, and whereas the twigs calculated as n minus 1, that is 3. So we get 7 minus 3 is equal to 4. So let us take a graph like this for the given oriented graph. So for this here we get the tree for this graph. A tree means it is a graph which connects all the nodes without forming the closed loop. So look at this. This is one branch, this is one branch, this is another branch. There are three twigs. For this oriented graph, one of the tree we can draw is like this. And in this graph, for this graph, the number of twigs that we get is 3. That means we should have only 3 thick lines such that they should connect all the nodes present in the main graph and they should not form the closed loop. So that is tree. So look at this. This is one of the tree where all the nodes are connected with the help of the twigs and the number of twigs are also fixed, that is totally 3. So to get the Cutset matrix for this tree, add the other elements as links, and that links are also fixed, that is 4. Look at this. This is one link, this is another link, this is another link, this is another link. There are totally 4 links. Once this is done, cut set means each twig will form the one cut set and the remaining elements connected to the that cut set node are links. So look at this. This is node 1 and this is the twig B. We cut it here at this node. The elements links connected are A, the other is D. Similarly, D also connected to this node 1 and B is the twig. Similarly, Cutset 2 means belongs to the at node 2. So here the twig is C, that is thick line, whereas the other two elements are the links, that is A and F. So this A, C are approaching the node 2, so their elements are going to get negative sign, whereas F branch is leaving from node 2, so they get the plus sign. Similarly, node 3, and here we get the cut set 3, is C3. Similarly, cut set 3. So here, cut set 3 has the 3 elements. One is the twig. So each cut set must have only one twig, and the rest are elements which are links. One is D, the other is F. This D and F, D is leaving the node 3, so it will get the minus 1 sign, sorry, plus 1 sign, whereas E and F are entering the node 3, so they will get the minus sign. Before we write the cut set matrix, form a table for cut set 1, the elements connected. Similarly, the elements disconnected to the cut set 1. Similarly, for cut set 2 also, identify the branches connected to the cut set 2. and the branches disconnected to the Cutset 2. Similarly, for Cutset 3, the elements connected to the Cutset 3, and similarly the elements disconnected to the Cutset 3. And disconnected elements will get the minus sign in the matrix, whereas the connected elements will get the plus 1 or minus 1 depending upon the direction of the element current with respect to the node of that cut set. So if you look at the cut set 1, the elements are B, G, D, A leaving, B also leaving, whereas G, D are entering. G, D will get the minus sign, A, B will get the plus sign. A, B plus sign, here plus 1, here also plus 1, whereas DG, because they are entering the node 1, so they get the minus 1 sign. And whereas the rest of the elements are disconnected elements, that is C, E, F, so they get the 0 values. Similarly, cut set 3, elements connected are D, E, F. So if we look at this cut set 3, the elements leaving the node 3 is D, whereas EF are entering the node 3. EF will get the minus, whereas D will get the positive sign. D is positive, EF are minus 1, minus 1. Whereas the rest of the elements A, B, C, G, they are disconnected to the cut set 3, so they get the 0 values like this. So we have seen how to get the cut set matrix for a given graph. So our first case, this is the Cutset matrix. So the rows indicates the node voltages, whereas the columns indicates the branch voltages. Similarly, for second problem also, this is the Cutset matrix. The rows indicates the node voltages, and whereas the columns indicates the branch voltages.